ਵਿਦਿਆਰਥੀਓ, ਤੁਹਾਡਾ ਅੱਜ ਦੀ ਕਲਾਸ ਵਿੱਚ ਸਵਾਗਤ ਹੈ। ਅੱਜ ਅਸੀਂ ਰੂਲਸ ਫॉर IUPAC nomenclature ਬਾਰੇ ਵਿਚਾਰ ਕਰਾਂਗੇ। nomenclature ਸ਼ਬਦ ਦਾ ਅਰਥ ਹੈ a system of assigning names। ਇਸ ਤੋਂ ਪਹਿਲਾਂ ਆਰਗੈਨਿਕ ਕੰਪਾਊਂਡਸ ਦੇ ਨੇਮਸ ਅਸਾਈਨ ਕਰਨ ਦਾ ਕੋਈ ਸਿਸਟਮੈਟਿਕ ਵੇ ਨਹੀਂ ਸੀ। ਪਹਿਲਾਂ ਕੰਪਾਊਂਡਸ ਨੂੰ ਉਹਨਾਂ ਦੇ ਸੋਰਸਸ ਦੇ ਹਿਸਾਬ ਨਾਲ ਨਾਪ ਦਿੱਤਾ ਜਾਂਦਾ ਸੀ। ਆਪਣੇ ਵਿਸ਼ੇ ਤੇ ਵਿਸਤਾਰ ਵਿੱਚ ਜਾਣ ਤੋਂ ਪਹਿਲਾਂ ਅੱਜ ਦੇ ਪਾਠ ਦੇ ਸਿੱਖਿਆ ਉਦੇਸ਼ਾਂ ਨੂੰ ਸਮਝ ਲਈਏ।
Upon completion of this topic, learners will be able to define catenation and hybridization, discuss general rules for IUPAC nomenclature, write primary, secondary, suffix and prefix for the functional groups, write IUPAC names of organic compounds.
Earlier trivial system for naming the organic compounds was used. As per this system, names derived were known as trivial names. For example, formic acid was derived from formicus because the compound was obtained from red ants. The liquid obtained from the destructive distillation of wood was named as methyl alcohol. The acid obtained from vinegar is known as acetic acid. The acid obtained from oxalis plant is known as oxalic acid. With the advancement of organic chemistry, the number of organic compounds increased rapidly. It is due to its catenation property. In order to rationalize the system of naming organic compounds, the International Congress of Chemists adopted a new system of nomenclature. It was known as Geneva system in 1892. In this system, paraffins were used for the nomenclature of aliphatic organic compounds. But this system failed for naming of complicated organic compounds. In 1931, the Council of International Union of Chemistry modified the Geneva system. As a result, International Union of Pure and Applied Chemistry, abbreviated as IUPAC, came into existence. Before going in detail about general rules for the nomenclature of organic compounds, first let's discuss about catenation and hybridization. Catenation. What is catenation? Which type of elements exhibit this property? Do you know, students? Carbon has a unique property of catenation. Well, catenation is a property of forming bonds with atoms of the same element, that is self-linking property. Carbon shows maximum catenation in its group, that is group 14 in the periodic table, because of greater carbon-to-carbon bond strength as compared to that of other atoms.
For example, as shown in this table, carbon-to-carbon bond dissociation energy is 335 kilojoules per mole. For silicon-to-silicon bond, dissociation energy is 220 kilojoules per mole. And germanium-to-germanium bond dissociation energy is 167 kilojoules per mole.
Therefore, carbon atoms can link with one another to form either linear chains of varying length or branch chains and even rings of different sizes as shown on screen. You will find that in all compounds, carbon atom is tetravalent. Catenation is responsible for large number of organic compounds. Tetravalence nature of carbon. The atomic number of carbon is 6. In its ground state, the electronic configuration is as shown on the screen. It is 1s2, 2s2, 2px1, 2py1, 2pz0. Since it has 4 electrons in its outermost shell, its valency is 4. You can see the 4 electrons flashing on the screen. To achieve noble gas configuration, carbon atom cannot lose or gain 4 electrons to form C4 positive and C4 negative ions because of the large amount of energy required for these processes. So, dear students, carbon has little tendency to form ionic compounds. It achieves the noble gas configuration only by sharing electrons with other atoms, and thus it forms covalent bonds in its compounds. Let us take an example. A molecule of methane is formed when 4 electrons of carbon are shared with 4 hydrogen atoms as shown on screen.
Now let's have a look at the classification of organic compounds. Organic compounds ਨੂੰ ਦੋ ਕੈਟਾਗਰੀਜ਼ ਵਿੱਚ ਵੰਡਿਆ ਗਿਆ ਹੈ। ਇਹ ਨੇ acyclic ਜਾਂ open chain compounds ਅਤੇ cyclic ਜਾਂ closed chain compounds ਜਾਂ ring compounds। cyclic ਜਾਂ closed chain ਜਾਂ ring compounds ਨੂੰ ਅੱਗੇ ਦੋ ਹੋਰ ਕੈਟਾਗਰੀਜ਼ homocyclic ਜਾਂ carbocyclic compounds ਅਤੇ heterocyclic compounds ਵਿੱਚ ਵੰਡਿਆ ਗਿਆ ਹੈ। homocyclic compounds ਨੂੰ ਦੋ ਹੋਰ ਕੈਟਾਗਰੀਜ਼ ਐਲੀਸਾਈਕਲਿਕ ਅਤੇ ਐਰੋਮੈਟਿਕ ਵਿੱਚ ਵੰਡਿਆ ਗਿਆ ਹੈ। ਐਰੋਮੈਟਿਕ ਕੰਪਾਊਂਡਸ ਨੂੰ ਦੋ ਹੋਰ ਕੈਟਾਗਰੀਜ਼ ਬੈਂਜ਼ੀਨੋਇਡ ਅਤੇ ਨਾਨ ਬੈਂਜ਼ੀਨੋਇਡ ਵਿੱਚ ਵੰਡਿਆ ਗਿਆ ਹੈ।
General rules for IUPAC nomenclature. According to IUPAC system, the name of the organic compound consists of 3 parts: word root, suffix, prefix. Let's start with word root. It is the basic unit of the name of the organic compound. It represents the number of carbon atoms present in the parent chain of the molecule. Parent chain is the longest possible continuous chain of carbon atoms containing maximum possible functional groups and multiple bonds present in the molecule.
Students, we are looking at table showing word roots for different carbon chains. For chain length C1, word root is meth. For chain length C2, word root is eth. For chain length C3, word root is prop. For chain length C4, word root is but. Similarly, for C5, C6, C7 and C8, word roots are mentioned in the shown table. In general, the word root for any carbon chain is alk.
After understanding word root, let's discuss suffix. The main functional group or principal group and the multiple bonds present in the given compound are indicating by adding specific suffixes to the word root. They are of 2 types: primary suffix, secondary suffix. Let's start with primary suffix. The suffix, which is used to represent the saturation or unsaturation of carbon atoms present in the parent chain, is called a primary suffix.
Students, we are looking at basic primary suffixes as shown in the table. If nature of carbon atom is saturated, it means that there will be single bond between carbon atoms. Primary suffix will be ane. General name of the compound will be alkane. If nature of carbon atom is unsaturated, it means that there will be double bond between carbon atoms. Primary suffix will be ene. General name of the compound will be alkene. If nature of carbon atom is unsaturated, it means that there will be a triple bond between carbon atoms. Primary suffix will be ine. General name of the compound will be alkyne.
Now students, can you guess what change will occur in the name if the parent carbon chain contains 2, 3 or more double or triple bonds? Well, then the numerical prefix like di for 2, tri for 3, tetra for 4, etc. are added to the primary suffix.
This table makes it more clear that if the parent carbon chain contains two double bonds, primary suffix will be diene. General name of the compound will be alkadiene. If the parent carbon chain contains two triple bonds, primary suffix will be diene. General name of the compound will be alkadiene.
Let's discuss secondary suffix. The suffix used to represent the nature of principal functional group present in the compound is called a secondary suffix.
Students, we are looking at a table showing the class of some organic compounds, functional group and secondary suffix in them. For alcohol, its functional group is OH, its secondary suffix is ol. For aldehydes, its functional group is CHO, its secondary suffix is ul. For ketones, its functional group is C double bond O, its secondary suffix is on. For nitriles, its functional group is C triple bond N, its secondary suffix is nitrile. For carboxylic acid, its functional group is COOH, its secondary suffix is oic acid. For ester, functional group is COOR, its secondary suffix is OAT. For amines, its functional group is NH2, NH and N as shown on the screen. Its secondary suffix is amine. For amides, its functional group is CONH2, CONHR and CONR2 as shown on the screen. Its secondary suffix is amide.
How secondary suffix is added to primary suffix? It is based on following rules. If the secondary suffix begins with a vowel, the terminal E of the primary suffix is dropped while adding secondary suffix to the primary suffix. If the secondary suffix begins with a consonant, the terminal E of the primary suffix is retained while adding secondary suffix to the primary suffix.
Addition of secondary suffix to the primary suffix is shown in this table. We are looking at a compound, word root, primary suffix, secondary suffix and IUPAC name having word root plus primary suffix plus secondary suffix. For the compound CH3, CH2OH, word root is eth, primary suffix is in, secondary suffix is all and its IUPAC name is ethanol. For the compound CH3, CH2, COOH, word root is prop, primary suffix is ane, secondary suffix is oic acid. Its IUPAC name is propanoic acid. In naming these two compounds, the letter E is removed as per rule already mentioned. For the compound CH3, CH2, Cn, word root is prop, primary suffix is ane and secondary suffix is nitrile. Its IUPAC name is propane nitrile.
It is time to discuss prefix. As the name suggests, it is placed before word root. There are two types of prefixes, primary prefix and secondary prefix. Primary prefix. It is used to distinguish cyclic from acyclic compounds. It is used immediately before the word root. For example, let us have a look at the structure shown on the screen. It is a cyclic compound containing 5 carbon atoms and is named as cyclopentane. Secondary prefix. It indicates the alkyl groups and functional groups other than the principal functional group are regarded as substituents or side chains.
Alkyl groups. Students, We are looking at some alkanes and relevant alkyl groups. Molecular formula for methane is CH4. If we subtract one hydrogen atom from methane, we get methyl group. Structural formula for methyl group is written as CH3. Molecular formula for ethane is C2H6. If we subtract one hydrogen atom from ethane, we get ethyl group. Structural formula for ethyl group is written as C2H5. Molecular formula for propane is C3H8. If we subtract one hydrogen atom from propane, we get propyl group. Structural formula for propyl group is written as C3H7. Similarly, alkyl group for butane and decane are also shown on the screen.
Functional groups. Some functional groups are always regarded as substituents and their presence is indicated by writing their prefixes before the word root. For example, Cl functional group is indicated by prefix chloro and Br functional group is indicated by the prefix bromo. It is important to arrange the different parts of the name as prefix plus word root plus primary suffix plus secondary suffix. The position of each substituent is represented by putting a suitable number before the corresponding prefix. Prefixes are arranged in alphabetical order and are separated by hyphens. If the primary suffix is "ane", the position of principal functional group is indicated by mentioning the suitable number before the word root. If the primary suffix is "ine" or "iron", the number representing the position of double or triple bond is written before the word root, while the number indicating the position of principal functional group is written in between primary and secondary suffixes.
Let's take an example to clear the concept. We are looking at an organic compound here. Let's select longest carbon chain in it. It has 6 carbon atoms in its longest chain. Word root is hex. Prefix used at position 5 is chloro and prefix used at position 4 is ethyl. Primary suffix used at position 3 is "ene". Secondary suffix used at position 1 is oic acid. As discussed, its IUPAC name can be written as 5-chloro, 4-ethyl, hex, 3-ene, 1-oic acid. Hence, IUPAC name of the compound is 5-chloro, 4-ethyl, 3-hexenoic acid.
Now, what are the rules to follow nomenclature of open chain hydrocarbons or organic compounds? Rules. Identification of the longest chain. The largest carbon chain in the molecule is identified. Students, we are looking at a compound. Let's identify its longest chain. Look at the screen. It is wrong way to identify the longest chain. If we look at the shown molecule, we find that there are only 4 carbon atoms in this chain. Is there any other way to find longest chain? Yes, of course it is as shown now. In this way, we see there are 6 carbon atoms in a chain. In this way, we find there are more carbon atoms than the previous one. It is the correct way to identify the longest chain. Numbering of carbon atoms in the longest chain. Numbering is done in such a way so that the branch carbon atom, that is the side chain or substituent, gets the lowest possible number. For example, let's have a look on the shown compound. Let's identify the longest carbon chain present in it. It is the correct way to identify longest chain. Let's start numbering in a different way. It is wrong way to identify longest chain. If a compound contains more than one substituent group, then sum of positions of carbon atoms should be the lowest number. It is also known as lowest sum rule. Let's take an example to clear it. We are looking at a compound. Let's identify longest carbon chain present in it. It has maximum 5 carbon atoms in its longest chain. Let's add positions of substituents attached here. Sum of positions is equal to 2 plus 4 is equal to 10. Let's start numbering in a different way. In this way, sum of positions is equal to 2 plus 4 is equal to 8. This is the correct way of naming. The previous one is the wrong way. Identifying the word root. The numbering of the carbon atoms in the longest chain tells the total number of carbon atoms present in it. For example, compound having 6 carbon atoms in its longest chain, it will be named as hex. Naming of alkyl groups. Names of alkyl groups attached as a branch are then prefixed to the name of the parent alkene, and the position of the substituents is indicated by the appropriate numbers. Alphabetical order is preferred in naming of more than one substituent group. If a substituent group is present more than once, use di, tri, etc. The lower number is given to the one coming first in the alphabetical listing. Carbon atom of the branch that attaches to the root alkene is numbered as 1, 2, 3 and 4. In alphabetical order, the prefixes iso and neo are considered to be the part of the fundamental name of alkyl group. The prefixes secondary and tertiary are not considered to be the part of the fundamental name. When only one alkyl group is present, it is named as 2-methylbutane. When similar alkyl group is present at different position, it is named as 2,2,3-trimethylbutane. Here numbering is done according to lowest sum rule. When different alkyl groups are present, it is named as 2-ethyl, 3-methyl, 1-butanol. Here numbering is done following the order of preference. Functional group will get greater preference than double bond will get greater preference than triple bond, and triple bond will get greater preference than side chain. When side chain is complex, let's take an example of the compound shown here. Let's start numbering longest carbon chain in it. As we are looking, its longest chain has 9 carbon atoms. Numbering of the longest chain is done according to the lowest sum rule. At carbon 5, we are looking at a complex side chain. Its numbering is also shown here. It is named as 5,1,2-dimethyl-propyl-3-methyl-nonane. In case there more than one functional groups are present, the order of the decreasing priority for some functional groups is shown as carboxylic acid gets greater priority than sulfonic acid, which in turn gets greater priority than ester, which gets greater priority than acid halide, which gets greater priority than amide. Amide in turn gets greater priority than nitrile, which gets greater priority than aldehydes. Aldehydes get greater priority than ketone, which in turn gets greater priority than alcohols, which get greater priority than amines, which get greater priority than carbon-carbon double bond, which get greater priority than carbon-carbon triple bond. Alkyl group, C6H5 group, and halogens like fluoro, chloro, bromo, iodo, nitroso, nitro and alkoxy are always prefix substituents. Naming of substituent groups in cyclic chain is done on the basis of alphabetical order. We are looking at a table showing name of functional group, symbol of that group, prefix and suffix for a particular group. For functional group alkene, symbol is shown in the table. Its relevant suffix is -ene. For functional group alkene, symbol is shown in the table. Its relevant suffix is -ene. For functional group alkyne, symbol is shown in the table. Its relevant suffix is -ion. For functional group halides, symbol is shown in the table. Its relevant prefix is -halo. For functional group alcohol, symbol is shown in the table. Its relevant prefix is hydroxyl and the relevant suffix is -ol. For functional group aldehydes, symbol is shown in the table. Its relevant prefix is formyl or oxo and suffix is -al. For functional group ketone, symbol is shown in the table. Its relevant prefix is oxo and relevant suffix is -on. For functional group nitriles, symbol is shown in the table. Its relevant prefix is cyano and relevant suffix is nitrile. Similarly, we can see other functional group, symbol of that group, prefix and suffix for a particular group in the shown table. Now students, we are looking at a compound having 5 carbon atoms in a straight line. It is known as parent chain. It contains 3 additional groups like CH3, Br and OH, out of which Br and OH are functional group, whereas methyl group, which is CH3 group, comes in the branch category.
We are looking at molecular formula of icosane and tricontane.
Students, now we are looking at isopropyl group, secondary butyl group, isobutyl group, tertiary butyl group and neopentyl group. Students, it's time to check your knowledge. Try to write the IUPAC name of the following compounds. Its IUPAC name is written as, its largest chain has 9 carbon atoms, hence its word root is non. Its parent hydrocarbon is nonane. This organic compound has these functional groups: C double bond O or keto group, Cl or chloro group, NO2 or nitro group, CH3 or methyl group, and C2H5 or ethyl group. As keto group ranks higher than other group, its primary suffix is -ane and secondary suffix is -on. Its IUPAC name is 4-chloro, 4-ethyl, 3,5,7-trimethyl, 6-nitro, 2-nonenone. Give the IUPAC name of the shown compound. Its IUPAC name is 5,6-diethyl, 3-methyl, 4-decene. Here is a question for you. Students, we are looking at some compounds. Try to answer which type of hybridization is seen in the following compounds. The answer is, the shown compound methyl chloride shows sp3 hybridization. The shown compound acetone shows sp3 and sp2 hybridization. The shown compound acetonitrile shows sp3 and sp hybridization. The shown compound formamide shows sp2 hybridization. The shown compound but2e nitrile shows sp3, sp2, sp2 and sp hybridization. ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਅੱਜ ਦਾ ਪਾਠ ਕਾਫੀ ਦਿਲਚਸਪ ਲੱਗਿਆ ਹੋਵੇਗਾ। Thank you for your attention and see you next time.